All right, welcome back, everybody. Before we get started on lecture, I wanted to show you something real quick. In case you don't check your announcements, there is a special event this Friday. The Women in STEM Club are presenting a researcher from Yale on breast and ovarian cancer. Now, you may be a guy and go, that may not happen, it's probably not going to happen to me. Well, the ovarian, no, but the breast could. And even if it doesn't happen to you, you probably have at least one person in your life that has had it, whether you know it or not, or will have it. So it's kind of a big thing. Hopefully they'll find a cure for it. It's from 1 to 2 in the John Muir building at 107. From 2 to 3, I'm tutoring in the JM 124 right in the hall. So like you could go to it, check it out, and come over and get some, help on homework, and check out the Mesa Center. If you're going into a STEM field, like engineering or physics or biology or chemistry, you'll want to be spending more time there as you go along because there's tutors for every STEM subject. It's a good deal. And then, yeah, that's it. Let's get back to math. Let's do some math. Where were we at last time? We were talking about polynomials, that's right. So this was an R, so what are we at day on? We're on, this is like day 5 of class. It's probably it might be listed as day 3 of lecture. I don't know, I gotta see which way I did it. And we're continuing R3, so this is like R3b, more on polynomials. And I realized I haven't uploaded the videos on Wednesday, but I didn't realize it until like 3 o'clock today. So yeah, your Slacker instructor will get that shit up tonight, hopefully, along with today's videos. So we talked about what polynomials were. Let's just start working with them. So we can add and subtract polynomials. When we do, what we're effectively doing is adding or subtracting the coefficients of like terms. So let's just special mention. Let's say we've got 7x to the third plus 2y squared minus y. That's one polynomial. And we're going to add to it 4x to the fourth plus 3y squared plus 2y plus 1. So when we say like terms, 2y squared and 3y squared are like terms. And negative y and 2y are like terms as well. They have the same variable with the same exponent. My unlike terms are the 7x cubed, 4x to the fourth, and plus 1. These have variables with different exponents. So they are unlike. And I'll put a like on this one. Like term. So I just got left to right. The 7x cubed doesn't have anything I can add to it. So we'll put it down. The 2y squared can be added to the 3y squared. And we're adding the coefficients, the numbers in front. So 2 plus 3 y squared like that gives us 5y squared. And I'll put little check marks on them as I add them. Negative y adds up with 2y, which is negative 1 plus 2 on y, which gives us, that's 1y. And rather than saying 1y, we just put y. Now I still have the 4x to the fourth. And I have a plus 1. We like to list them in descending order, which means by exponent size. So the biggest exponent here is 4x to the fourth, then 7x cubed, then 5y squared, plus y, and then plus 1. You guys ready for more? Not everyone is. I see some kids still moving. I'll be patient.
So the way that it's listed is also, it has to be in that way, that is the correct way, if not, it would be incorrect. Or if we had,
I would mark you down very little for having it in the wrong order. But you should put it in descending order. The reason why is, as you get more familiar with how this stuff looks like on graphs and stuff, and if you take calculus and things like that, you will. You can tell right away by looking at the first term, if it's the largest, what the overall shape of the graph is going to do. Just flat out. Now, generally, we won't have mixed variables like this. You only have x's with maybe like y equals it. Did you pass some love notes? It's all good. No shame. Drew might feel left out though after their little pixels thing.
I'm lonely right now.
Right?
Being one.
That's some depressing shit.
ain't nothing wrong with being done.
That's everything. From
No, there's nothing wrong with being alone.
There you go, no, yeah. So.
Lonely is a different fucking thing than alone. They sound the same. They have the same relationship status, but one you're happy with it, and one you most definitely are not. And if you've grown used to being lonely, that's
a special kind of hell.
that kind of hurts a little bit inside. That's one of those things, you gotta be lonely for a while to get like used to it.
I mean, it could be.
Alright. Alright. Let's do some subtraction. You're fucking cracking me up. Let's do, let's have negative 6x cubed. Minus 11x squared. Plus 21x. And we are gonna subtract. X to the fourth. Minus 6x squared. Plus 4x minus 2. So when we subtract, and if it's in parentheses like that, we need to make sure that the subtraction hits everything. We're literally going to distribute that subtraction sign to each thing. And the effect is just change the signs. So first thing we'll do, I'll rewrite the ones we already got. And then I'm going to go through and change the signs, drop the parentheses, change the signs. Positive x to the fourth becomes negative x to the fourth. Negative 6x squared becomes positive x squared. Positive 4x becomes negative 4x. And negative 2 becomes positive 2. So let's go through and add them up. I don't see anything with the one way to do this to get it all done in one fell swoop is start with the largest exponents and go down. So I've got a negative x to the fourth right there, and that's the only thing with an x to the fourth power. So that goes by itself. This is the only x cubed. So I've got negative 6x cubed. I've got negative 11x squared plus 6x squared. Negative 11 plus 6 is negative 5. So that becomes a negative 5x squared. And then 21x and negative 4x both have exponents to the first power. 21 minus 4 is 17. So plus 17x. And finally, plus 2. Now, you might find it handy to do what I did there. As I went through it, I underlined it, and I use a number of lines matching the exponent. Generally, when I get to like the fourth power or higher, I start doing like lightning bolts and shit like that. But like for teaching purposes, I wanted to like make sure it's clear. What underlining for is good for is when you're done, you can go through and look at it and make sure you did them all. And then if you're checking your work later on, this really speeds up checking your work because you can see what you paired up. Which is a good thing. Being able to check your work is a good thing. Let me give you guys one. What am I gonna do with this 2 outside and this 3 outside?
Got multiply, so let's read them over.
You gotta multiply them through. So make sure you do that. The 2 hits everything in that one. And the -3 hits everything in this one. Go ahead and work this out, see what you get, and we'll do it together in a minute or two. Alright, let's see what we get. What do I get when I distribute the 2 into the first parentheses?
2y squared. Let's see.
Yeah, looks good. What about this -3 over here? What happens when I do that one?
That with negatives, yeah.
+12. Yeah. So the negative changes the signs and then we multiply the 3 through. We will collect like exponents. So 2y squared and -6y squared. For those of you that are, I'm gonna do this one a little slower. I'm putting those 2 together. And this is like 2 minus 6y squared to give me -4y squared. And then on the -8y and the -3y. It's almost like, rather than distributing, we're doing the opposite of distributing. I'm pulling the y out rather than putting it in. And we're gonna talk about that in a second, that's called factoring. And 6 plus 12 is 18. And there's no sign there, so we gotta put a plus. So -4y squared minus 11y plus 18. None of that yawning shit, who the hell is doing that? No. That shit's in pages. Alright, so rather than multiplying coefficients through, what if we up this shit? Plus Xavier. If you distribute the negative to the other side. What do you mean by that, Xavier?
Oh, can you hear me?
Yeah, I can hear you.
Oh, like the previous question that you had before was just the negative alone. What if you
Uh-huh.
distributed it backwards? Yeah, would it make a difference?
What do you mean by backwards?
Like the other side, my bad. Not the right side, the left side.
That would be the wrong way,
Okay.
because we're subtracting, everything would be actually the wrong sign. It should end up being the wrong sign at the end. Because just like we wouldn't say, if we had 5 minus 3. And I had the 3 in parentheses like that and a 5 like that, we wouldn't make this -5 plus 3. Because that would give us -2, which is wrong. Gotta keep it going forward to the right.
Gotcha.
Good question. All right, so here we were multiplying constant numbers through. What happens when we upside that shit? Let's change it. What about multiplying through like x squared times 3x cubed plus 4y squared plus 2y minus 1? Well, we again gotta do it times each term. I have x squared times 3x squared plus x squared times 4y squared plus x squared times 2y plus x squared, times -1. It is cute, thank you. So, what do I do with this?
That would be adding the exponent.
We add the exponents. Get 3x to the 5th power. What do I do here?
Oh, wait, no.
Can I add the exponents?
No,
Why not?
4x squared and y squared. Because they're not the same.
Yeah.
Is everyone like that? That's correct. They are not the same variable as the base, so we can't add the exponents. Same thing is gonna happen with the rest of these. So here we're starting to multiply polynomial stuff. And now let's just go up to something like 4x minus 5 times 2x plus 3. Now
Sorry, going back to the last one.
yeah,
Because the y doesn't have an exponent, it wouldn't be correct to put it on the end since we're going in descending order, it doesn't have.
well, the x squared and the y cumulatively, that's a really good question. When we're looking at the degree of a term, we look at all the exponents added together for variables. That counts as a 1, so this is a 3rd degree term. That's a 2nd degree term. That's a 4th degree term, and that's a 5th degree term. Excellent question.
I had a feeling I was just sure, so.
It's a really good question. So this stuff you guys might have seen, it might have been introduced to you as a bunch of different things. You might have learned FOIL. You might have, I don't know, made a diamond. Some people learn to cross sticks. But the easiest way to just do it, which works every single time, some of these require having just two things in each parentheses, is we're gonna distribute, but we're gonna distribute this to everything. So we'll have 4x times 2x plus 4x times positive 3. And then we do the same thing with the -5. -5 times 2x. -5 times 3. So what do we get as we're going along? 4x times 2x is,
That's it, squared.
it's 8x squared. We multiply the numbers and then the variables. 4x times 3 is 12x. -5 times 2x is -10x. I'm gonna stack that below the 12x. Because it's got the same exponent, variable and exponent. And then -5 times 3 is -15. And I can add vertically. 12 times -10 is 2. Then we have our next one. Is there any questions on that? We're gonna do 3x plus 2 and times 3x minus 2. Why don't you guys give that a try, see what you get. Well, anyone need longer? Saw thumbs up, so I gotta, yeah, oh, I see pins still moving, what am I doing? Why am I even asking? I can see pins going. Stupid question. Alright. Let's do the distributing thing and I'm gonna just do it one at a time rather than writing out this line. I'm gonna just do the first parentheses. I've got 3x times 3x. 3 times 3 is 9, x times x is x squared. And then I'll do it times the -2 and I get -6x. And now I'll do the next one, I'll do the +2. +2 hits the 3x and makes +6x. And I'll stack that underneath my other x term. And then 2 times -2 is -4. So the way I've done it. This first one is all listed as the first line. And the second one is all listed as the second line. And I've stacked up things that matched by exponents. When we add them up, something magical happens. The 6x's cancel and we have -9x² minus 4. Does anyone know what this is a pattern of, the name for it? I know you know the name of it, one of you guys knows the name of it. Got a special name. We are simplifying, but like, that's not it. Subtraction is called difference. And this is really 3x squared minus 2 squared. This is called difference of squares. And what happens with that is when you have a minus b times a plus b, it ends up being a squared minus b squared. That middle thing always gets wiped out. And you can see that for yourself if you multiply this out. You got a squared plus ab minus ba, but that's the same thing as minus ab. And then minus b squared. These two cancel out. And I'm left with a squared minus b squared. This is used a fucking lot in calculus. I'm teaching that calculus class, and some of them don't fucking remember different squares, and it's making it really fucking hard for them. So let me just splash you with a little bit more different squares. Why don't you guys take a shot at 2x minus 7, 2x plus 7. And then let's do x cubed times x minus 1 times x plus 1. A couple of people said factoring. Factoring is when we go the other direction, when we rip the thing apart. And we will be hitting that today.
Are we solving this one?
Yeah. Yeah, try to figure it out. It's like I need to go through and edit the schedule. Because like today, I have listed that we are gonna be doing the second half of R4. We haven't started R4 yet. We're going to, but. Which means I'm gonna go through and edit all the homework due dates, get more time. That's always fun. Not really. So. The quick way is to recognize. This is A minus B. This is A plus B. And writing that as A squared minus B squared. So A is 2x and B is 7. So I have 2x squared minus 7 squared. And make sure when you do the squaring of the 2x, you square the 2 also. That is 4x squared minus 49. The longer way involves multiplying that out. You'll distribute the 2x to each of those. And you'll have 4x squared plus 14x. And then you'll distribute the negative 7. Negative 14x minus 49. And when you add them together, you still get 4x squared minus 49. These two up here pass more notes than you guys back there. They share pencil sharpeners, they share notes. Next thing I know, I'm gonna hear there's a fucking like wife swap thing going on in this motherfucker. A girl swap. Partner swap. I don't want to assume you guys like girls. You never can tell. Oftentimes you can get a good feeling. You can usually like identify.
He just said he has a wife, so.
Oh, I didn't catch that part.
Oh,
Did you?
yeah, he did.
I missed that.
Okay.
Is that why the kids smuggled you candy? She doesn't want you to eat it, so it's like you don't get it, give it to the kids, and they're like, Daddy. We love you, Daddy, even if Mama doesn't. If Mama won't let you have no Butterfinger, but we love you, Daddy. All right, on this next one, you may be inclined to just start on the outside and start multiplying through, but this is actually easier if you do this one first. This follows the same pattern. So the A is like the X and the B is the 1. So I want A squared minus B squared is X squared minus 1 squared or X squared minus 1 for that part. And then we're going to distribute. And X cubed times X squared minus X cubed is X to the 5th power minus X cubed. Now in each of these, I put the minus first, but that's not necessary. If we have X plus 2 times X minus 2, it's still an A plus B, A minus B scenario. We still have both things present. So this will be X squared minus 2 squared, which is X squared minus 4. The homework though likes to pull some shit on you. Like really like crap on your day. So they use different variables. So like let's work out an example and see what's happening with it. 3x minus 2y times 4x plus y. Multiplying this out isn't too bad. Going the other direction, factoring, is a pain in the ass. And that's where they'll stick it to you. So I'm gonna multiply these out and I'm gonna have 3x times 4x. Doing this set first, that's 12x squared. And then 3x times y. They're different letters, so I can't combine them. I'll just leave them like that. Now we'll do the same thing with the negative 2y. Negative 2y times 4x. I've got negative 8. And if you write the letters in the order they're in, you can. So I'm going to. Just to point out what happens when you do. And negative 2 times y is negative 2y times y is negative 2y squared.
You had mentioned that those two are the same thing.
Yes. Just like 2 times 3 is the same thing as 3 times 2. Y times x is the same thing as x times y. The commutative property of multiplication means I can make that negative 8xy and I can combine those two. So if I do, I'm going to have a 12x squared. I'm going to have a negative 5xy and a minus 2y squared. Now, this is identical to leaving the y first. But if you do this shit, Hefe is gonna make fun of you. Because everybody's got a little ADHD in them and fucking alphabetical shit, people. Put the goddamn shit in alphabetical order. What?
That's what you call us up.
Call you out of class.
Call us out of class.
If I, yeah. Yeah, to answer that fucking backwards, you see what happens. You see what happens when if you do it. It won't just be Louis and Luis that I'm fucking with all the time.
Louis.
It fucking looks like Louis, goddammit.
Lois.
Lois, that's better. Lois. No, that sounds like I'm fucking harassing a student. The rest I can write off as fucking just
Friendly Benson.
friendly bantering. But if I start saying Lois, it sounds like I'm first off calling him a girl. And second off, why would I call him a girl? That might sound like I'm trying to be derogatory. There's nothing wrong with being a woman. I assume, I don't know, I've never been one. But I've met a lot of brilliant women. Some of them are a shitload fucking smarter than me. And some of them are a shitload fucking stronger than me too. Summer school, I had 2 students. This was fucking tripping me out. Fucking mindful, this is tough. Tell me if this seems fucking normal to you. So I got one student, he says, I don't know how it comes up, but like, I find out that his mom is like a competitive weightlifter, like a bodybuilder. Like the whole, like the shiny, like looks completely out of proportion, not attractive at all, competitive. I don't know if she is or not. I don't know if she's all super like too far, but he just said competitive bodybuilder. And I find out like near the end of class, like 1 or 2 days before, the other kid who in the class that are both like juniors or seniors in high school, they live next door to each other, and I knew that. But turns out the other guy's mom has done competitive bodybuilding too. What are the fucking odds that 2 people that didn't know each other before like end up moving right next door to each other, both having kids the same age, and they're both female competitive bodybuilders, which is a lot less of than men. It fucking just seemed like, wow, this is abnormal. Yeah, so after I found out they were competitive bodybuilders, I stopped. I said I was gonna stop making fun of them because I didn't want their mom to come kick my ass. But I didn't really stop. All right, okay, let's kick it up a notch. We've been doing 2x2s, but fuck all that.
Sorry, you can go back just to take a picture. Sorry.
Yeah. I told a long story there, Josue. That shit should have been fucking written by now. You know that? I would say I'm gonna scan it and
Thank you.
it'll be but we saw what a slacker Hefe was on Wednesday, because that shit still isn't up. So when I get home tonight, I need to go fucking find it and post Wednesday's notes. All right, since Luis isn't fucking looking like he's trying hard enough, and Jimmy's answering for everybody else, you can all fucking struggle on this one. Oh, yeah. Yeah. I suggest you do them one thing at a time. Make a new line for each one that you do. Like do the x squared is one line. The 5x is one line. And 4 as another line. And add them up. And you will find that this may not be as hard as it looked. Barking spider. They're really bad this time of year. Surprised they haven't sprayed yet. Should take care of that, right? You ever heard that?
Mark and Spider.
Yeah.
That's hilarious.
Have I told you guys about the Chipotle protocol?
No.
Chipotle protocol hopefully never has to be unleashed in this class. Chipotle protocol is it works really well for the afternoon classes, but the morning classes not so well. If there's ever a day where like you guys are just out of hand and I warn you and you keep going, the next day class meets, I'm having Chipotle for lunch, I'm shutting that fucking door. And whatever happens, happens. And I want you to fucking call me on it, Darian. I dare you. Call me on it.
For the sake of everyone here.
Cry me. You what, but it's not a problem. It smells like chocolate chip cookies. Makes you hungry. That's a good part. When you know when you get a whiff of a fart and it makes you hungry.
No, that was. I think that might be you, just you.
No, it's never happened to me once. It's fucking sounds great though. I'm a big fan of the elevator silent one. Even better with right away, like people in there are like, you smell fire?
Fire.
Fire. When you ask if someone smells fire, at least 95% of people instinctively inhale through the nose to check for smoke, because fire means pain and death.
Oh, there's popcorn.
Yeah, but fire, if they don't like popcorn, they're not gonna smell for it.
I get it.
Fire though, it's a survival thing. You inhale to check for smoke because you're in a fucking trash thing like an elevator. If there's a fucking fire going, we need to start getting out ASAP. So you make sure they're not being mouth breathers. Take a nice good, like, not just like slow inhale, but people like take a deep sniff when they're checking for smoke. It's good stuff. All right, so I'm going to distribute this first x squared times x squared is x to the fourth. X squared times negative 3x is negative 3x cubed. And x squared times positive 2 is positive 2x squared. Then there's the cauliflower rice activation protocol, codenamed CRAP. Cauliflower rice is fucking worse than like refried beans. That shit makes you gassy and it's nasty. Oh my god. Cauliflower rice is where they like grind up cauliflower and make it look like little like rice grains. It still tastes like fucking cauliflower, so you're not tricking anybody. But some people are more likely to eat a cauliflower. That's some ripe shit right there. All right. Now that I'm done entertaining myself up here, 5x times x squared is 5x cubed. I'm going to stack that underneath the x cubes. 5x times negative 3x. 5 times negative 3 is negative 15, and x times x is x squared. So negative 15x squared goes there. And 5x times 2 is 10x. Finally, we're distributing the 4x squared. 4 times negative 3x is negative 12x. And 4 times 2 is 8. If you stack them up like I did, addition becomes really easy. You have everything in the same correct columns. This is x to the 4th. Negative 3 plus 5 is positive 2. 2 minus 15 is negative 13. Plus 4 is negative 9. I think this might be easier to do the 2 and the 4 first. 10 minus 12 is negative 2. And then I have 8. Be on the lookout. Let me finish letting people write this one. Yeah, he's a little unorthodox. Something different about Jones. He's got crazy. In a weird way. Not like crazy, like I'm worried that he's gonna fucking try to bite my ear off crazy. Just like fucking weird. But memorable. Alright. Looks like people, oh no, Jimmy's still fucking writing. No, I'm fucking around. Take as long as you need.
This one said.
Let's take a 5-minute break while Jimmy's working. To use the restroom. We got 2 hours. We should take a break. I shouldn't fucking keep you busy the whole time. I hit pause. I'm gonna get in trouble, even though I'm clearly joking. All right. Oh, here's some shit they'll pull on you. This is great. Now, you can clear the inner parentheses. Just get rid of the parentheses, like they're not doing anything inside. But you could recognize if I call this A and this B, that's also A and that's also B. This is A squared minus B squared, where A is the 3x minus 1 and the B is the 2y. Now the 3x minus 1, when we have it squared like that, that does mean this. So you might need to multiply that out. You're going to get 9x squared minus 3x and then minus another 3x plus 1. So that first part is 9x squared minus 6x plus 1. And then I bring that down and I have minus 4y squared. So every once in a while, they'll do some shit like this on you, but you can make it shorter if you do differences, recognize that it's a difference of squares.
So where's the brackets?
They're like
Just grouping.
parentheses.
Just moving.
Yeah, just grouping. Yeah, that makes this look like bracket A minus B, bracket A plus B. It's still just grouping. Homework likes to do that shit on you.
Yeah.
Now, the next subject might very well be Luis's favorite fucking topic this entire semester. I know it's one of mine. It's a good subject. Students fucking hate it. We've added polynomials, we subtracted polynomials. We've multiplied polynomials, what's missing? Division of polynomials. So, how do we divide polynomials? Does anyone need this longer? Alright. Dividing polynomials, and then we'll get R4.
I mean, sorry. I didn't finish that.
You have this way.
There you go.
Alright. I'm gonna show you division without, like, just numbers first. Long division, good old fucking long division. 132 divided by 5. Or 132 divided by 5. There's no variables here. But if we do this, we have 132. We check to see how many times 5 goes into a 1. 5 doesn't go into a 1, so 0 times. And so then we check the next number. 5 goes into 13, 2 times. I take the 2 times the 5, and I get a 10, and then I subtract it. 13 minus 10 is 3, and I bring down the next number. 5 goes into 32 6 times. Then we do the 6. 6 times 5 is 30. And then we subtract it, and we get 2. And you could do decimals, but we're not going to do decimals. We're going to say that's our remainder. So 132 divided by 5 tells us that this is our outcome, 26, with a remainder of 2. R stands for remainder. That's good old long division when you learned it in elementary school. It's been a while, if you learned it. I had to have been taught to you. Whether you learned it is another story. How does this compare to polynomials? I'm going to set it up the same. X minus 2 is what's on bottom. It's being divided into x squared minus 4x minus 7. I want to make sure everyone's with me when I get started. So I have the problem ready, written, and just like flow with me, get our jam. So just like up here, we check to see how many times 5 goes into 13. I need to do that down here, but we're only going to focus on the thing with the biggest exponent, the x. And we're going to see how many times that goes into x squared. So you can literally just do x squared divided by x. That should give you x. And that's what I'm going to put up top up here. Then I'm going to take this, and I'm going to take that x, and I'm going to multiply it by the x minus 2. Because that's what we did here. We like 5 into 13, it went in 2 times. We took the 2 and we multiplied it by the 5. Here we're going to take the x and multiply by the x minus 2. So it's the same process. We're going to do x times x minus 2. That is x squared minus 2x. Then what did we do? We subtracted. Since there's more than one thing there, I'm gonna put it in parentheses. You might find it easier to make a little note and move the signs inside by changing the signs that are present. Remember, we had a minus on the outside parentheses earlier and it just changed the signs? Same shit's going on here. So this will be x squared minus x squared is 0x squared. And I've got negative 4x plus 2x is negative 2x. So make sure you're doing the plus there, the opposite of what it came as. We don't need 0x squared, we never talk about having 0 of anything. So the important part is the negative 2x. That first thing should cancel out every single time when you do division with polynomials. If you multiply through and then subtract, it should always go away, 100%. Then we do it again. I need to see how many times x goes into negative 2x. Here the x's cancel and I get negative 2. So that'll be what goes on top. And I take the negative 2 and I multiply it by the x minus 2 that's out front. And that becomes negative 2x. And the negative 2 times negative 2 is positive 4. We bring down this 7, the negative 7. And we have a minus there that we're going to distribute. The minus makes this a positive and that a negative. So negative 2x plus 2x goes away. Negative 7 minus 4 is negative 11. One thing I want to go back and do on the first thing we did right here. Another way of writing this is 26. And then taking the remainder and putting it on the top of a fraction. And taking the denominator that you divided by and doing that. So rather than saying remainder 2, you could say 26 and 2/5. Which is the same thing as 26 plus 2/5. These two things are identical. But Jennifer? Get in trouble?
Not too much, my kids have been. Could you help me?
It's funny because I love my keys at home too, but I give it a half hour for office hour. And I thought, so I didn't have office hours a day. I drove home and got them. We both forgot
That would be
them.
my half an hour, then I'm supposed to be here.
Right. We both forgot them. That's great.
Thank you.
Yeah. All right, so we're gonna do this here. So what goes on top? So we had x squared minus 4x minus 7 divided by x minus 2. What we have on top is our answer. And then we have plus our remainder goes on top of the fraction. And our denominator goes on the bottom. So you could, instead of writing plus a negative 11, you could write it as that. Wow, I randomly chose those numbers and it's just coincidence that they're both x minus 2s. This and this is coincidence. We're gonna do another one. We're gonna upsize it.
It's right to.
So here I have positive,
No, like up more. Like, parentheses, so this is just for the-
in parentheses.
Yeah.
We're subtract, just like we were subtracting here. When you subtract, it's, we need to distribute the minus sign. So like, if we had. -1 times 4x minus 7. Am I answering the wrong question? Alright, so
It's the one above that.
up here,
It's in the blue, right? It's the negative and then it's x squared minus 2x.
right here.
Yeah.
And what's your question?
It's the 2 we're not supposed to be 2.
No, because I'll show you, because we had. This was -4x. And we're adding 2x.
Oh.
Good,
Okay.
that's great, that was much easier to point out than re-describing everything, awesome. Alright, you wanna go harder? Let's kick it up a notch.
Thank you very much.
You're welcome. Yeah, more power. 7x to the 4th power plus. No, probably minus 3x squared. Plus 5x. Minus 2. And we're gonna divide that by. X squared plus 2. Might as well make it just as bad as we fucking can right now. This is about as bad as it gets. When you go to write this as division. Put in 0 for any term that's missing. So what I mean by that is x squared plus 2, there's no x in this. So I'm gonna say x squared plus 0x plus 2. And in the big thing on the top, the numerator, there's no x cubed. So I'm gonna put in a 0x cubed. If you don't, everything is not gonna line up, and then like people will try to add and subtract shit that doesn't add or subtract. Alright, we're still doing the same process though. How many times does x squared go into 7x to the 4th? You should get 7x squared. So that's what I'm gonna put up here. I'm gonna take that 7x squared and I'm gonna multiply it by this stuff right here. So I need to multiply by x squared plus 0x plus 2. And that gets me a 7x to the 4th. Plus a 0x cubed. Plus 14x squared. And I'm making sure, even though it's a 0x cubed, I'm actually putting it in there. Because now I can see my shit lines up. And if I don't, it's really easy to try to put the x squared underneath this. And x squared doesn't go underneath this. So I'm going to distribute a minus sign. And this becomes negative, that becomes negative, and that becomes negative. The first thing should go away. Conveniently, the x cubes are a 0 also. So we just have negative 3x squared minus 14x squared. Negative 3 and minus 14 is negative 17. X squared. And I'll bring down the rest. And we're gonna repeat the process. How many times does x squared go into negative 17x squared?
I have a question real quick.
Yeah,
Where did you get the 0x cubed?
I put it in there because there was no x cubed up here. And if
Oh,
I
okay.
don't, I'm gonna fuck it up.
Okay,
This is the pro tip. 'Cause otherwise, shit doesn't line up later on.
okay, thank you.
You're welcome, good question.
Basically just there as a placeholder.
It's a placeholder, that's exactly what it is. If you're one of those people that has a fucking shoe rack. The shoe rack's empty for the shoes you're wearing. Is anybody in here a shoe person? To the point you have a rack? Crazy motherfuckers. Both of them, anybody on Zoom, a shoe person? Has a shoe rack? I was not expecting that only guys were gonna answer that as a yes. I figured if there's any fucking shoe psycho in here, it was a female. I got fucking sneakers, pair of business shoes, and when I can find them in my fucking flip-flops. Not flip-flops, but like kind of like Birkenstock sandals, but not like the thing between the toes.
Those are the ones that always.
Mine go missing because I'm married. My wife fucking hides them because I am one of those people that says, I don't care what other people think. I find sandals and socks fucking comfortable. My feet don't fucking get dirty. They can still breathe. They're like the socks are thin. So they're not getting dirty. And my wife is like, the only fucking fashion thing she ever follows is sandals and socks are bad. So she fucking hides my sandals because she knows I'll wear them with socks. They fucking disappear. I stopped buying. This is a negative 17 here. That's gonna go above my x squared. Just to help me keep track of shit. And I'm gonna multiply the negative 17 times that x squared plus 0x plus 2. And when I do, I get negative 17x squared minus 0x minus 34. You guys with me? We're gonna subtract, which means going through and changing all the signs inside. And adding them up, I have 5x plus 32. Let's try the division again. I want to see how many times x squared goes into 5x. 5x on top, x squared on bottom. And this is a stopping point. When the degree of the remainder which is our 5x, is larger than the denominator. Sorry, not larger, smaller. I was about to say demonator. Fucking bottom. Stop. So this is our stopping point. We got 5x here, we got x squared out here. X squared does not go evenly into 5x, so we're gonna stop. We would have to have a negative exponent if we continue, and we don't want that. So 7x to the fourth minus 3x squared plus 5x minus 2 over x squared plus 2. I'm leaving out the zero things now. I'm just writing the answers. I have 7x² minus 17. And then I have plus 5x plus 32 over x² plus 2. That should be as bad as the homework gets on division of polynomials. I had 0 spots in both the numerator and the denominator, and I had something that was not just x in the bottom. That's good. How many people like this? If you don't like it, Luis, you can be honest. It's all right. I like it because it's like regular division. And it makes everybody else's head explode, so I feel super smart because I'm like, that's not too bad. It's just division. It makes me feel smarter, which is a shitty way to go out doing it, but hey, fuck it. That's what it is. I see some pins still moving. Let me wait a little bit longer. All right, we're gonna start R4 here. In fact, let me hit stop on the video and start a new video. That way there'll be 2 videos that are separated by the section. Stop recording.